and you have done some analytical result. Now your target will be how you will validate that. How it is possible? It is not too easy to possible. It is validated. Because during the process of validation, you must have to consider or collect some data, and that data must be real data. That has been mentioned. And after that, during the formation of the mathematical model, after that your formulated mathematical model, your analytical results, your model validation considering all data, and also the result which you are getting after all this done, then you just have to project it. That means the intervention, obviously that should be revealed or focused in the society. Now, previous outcome, before going to your formulated mathematical model, whether there are any such type of work has been done or not, that should you have to recheck. So that you will get some knowledge during the reviewing process, and that should be reflected when you are doing all this research work. That I have mentioned here, that is the previous outcomes, that is combining interventions, targeted settings, impact of new technologies, and advocacy. All this must be reflected after completion of your research work. Now, just I will give a little bit introduction which has already been introduced by Professor K. That is SIR. Little bit he has been mentioning. That is SIR. S means susceptible, I means infectious, R means recovered or immune, that is SIR. S, proportion of population, that is susceptible at time T. Proportion of A number, that is currently infected and infectious at time T. Proportion of A that is recovered during that time. SIR mode is used to predict the three proportions at different scenarios, and SIR model can be adapted to SI model, susceptible infected model, susceptible infected susceptible model, susceptible infected recovered susceptible model, and SLRI, susceptible latent infected recovered model, etc. This categorically can be reflected during the formulation of the mathematical model. In a nutshell, SI model, SIS model, SIRS model, and SLIR model. Now, basic reproduction ratio. Yesterday, so many of our students or researchers have been asked, or during the hearing of the lectures of different lectures, I have been informed that our students or researchers are very much associated with basic reproduction ratio. Though I have mentioned here, that is the number of people that one sick person will infect on average is called R0. Here are the maximum R0 values for a few viruses, that is, suppose here hepatitis, Ebola to HIV4, SARS4, mumps. So many people can be infected from a person, and yes, that is 80 people are being infected, or they have the capability to infect the other people, that is number of 18 or 16. Now, effect of vaccination. We try to give the vaccination during the process of infection or before the infection, that is infections for which the immunity acquired by natural infection can be assumed to the lifelong hepatitis A, varicella, mumps, rubella, and infectious stages, that is susceptible, latent, infectious, and recovered immune, that is R. Just you have to follow here. These people are being vaccinated, S and R, and this is that has the direct effect, and the indirect effect, the people, those who are infected, and these are the latently infected and actively infected. It has the indirect effect getting vaccination. Now I will try to little bit discuss about the how can we explain in 1984, initially, first, it was discovered that HIV, that means the human immunodeficiency virus. Human immunodeficiency virus, HIV. And in a nutshell, it is to be described as AIDS, acquired immunodeficiency syndrome. AIDS. And what is AIDS? AIDS, to come into possession or something means I means immuno, D means deficiency. It is diseases or weakness in the body's ability to fight off infections and illness. And syndrome, it is specifically clarified by that is a group of signs and symptoms that occur together and characterize a particular abnormality. So these AIDS is basically clarified literally in that sense, and HIV virus, that all this actually AIDS. HIV enter when human immunovirus entered in your body. It does not mean the person being to be treated as the AIDS patient. When HIV entered in your body, I know everyone, you know about how it is to be entered in your body through illegal relation. Sometimes the syringe that inject your body, basically that is the blood transmission. During the process of blood transmission from one infected person to another uninfected person, if it is happened, then obviously human immunodeficiency virus, that is HIV, it is to be entered in your body. Now, it does not imply HIV when entered in your body that the people is to be treated as AIDS patient. No, it has a name, has a threshold. Beyond that threshold, when the HIV counting of HIV is beyond that threshold, then the people will be treated as AIDS patient. People will be treated as AIDS patient. That's why I have mentioned HIV is the virus that causes AIDS. Ultimately, if you take necessary action or prevent to kill the virus, if you treat the people, then such position will not be happened, that is AIDS position. Not everyone who is infected with HIV has AIDS. Everyone with AIDS is infected with HIV. AIDS is result of the progression of HIV infection. But I have told you, that is beyond that threshold value, counting of HIV, the people will be treated as AIDS patient. And thus, anyone infected with HIV, although healthy, can still transmit the virus to another person. What does it mean? It means that I am 19 years of diabetic patient. I have 2 stents in my heart. But still I am working, and some of you will not be understand that I am basically involved with health related immunity. Because of I am maintaining all these issues. I have repeatedly telling your administrator that I need this type of food. I need this. I need this. Otherwise I will not be run out of my normal life. So a AIDS patient, he has that capability. He is a healthy. It does not imply. If I touch you, I am a diabetic patient. It is not the transmissible disease. But the AIDS patient, only AIDS, he is very healthy, very healthy. But his blood is transmitted with an uninfected person. That means that HIV entered into the body. And to some extent, that people must be moved forward to such a position that is beyond the threshold value of HIV, he will be treated as an expression. If he do not take any necessary measurement or necessary action to explore that HIV infection. Am I clear? Now, what is the how HIV entered? I am just telling you a story. We are the people. We have CD4 plus T-cells. We have so many cells. T-cells. T-cells means immune cells. T-cells means immune cells. CD4 T-cells, CD4 T-cells, CD8 T-cells, CD8 in CD16, CD25, CD28. So many immune cells. But CD4 is most essential T-cell. CD4 T-cell. How it is to be? It is generated in our body. We have a bone marrow. In our body, we have a bone marrow. Constantly from that place, this blood cell is occurring. Constantly. This cell is occurring. And another place in our body, in immune system, that is called thymus. Occurring from bone marrow, this cell is to be matured to the thymus. Right? From thymus, this CD4 T-cell is exerted, circulated in different parts, or total immune system. Right? We have considered this T-cell. This is the T-cell. Have you seen the antenna? Long before TV antenna, right? TV antenna. This is the like a slit antenna. This is CD4 plus T-cells, and this is the receptor. This is called receptor, like an antenna. Now just you have to follow me. This is the antenna, and this is the particle HIV. It is trying to enter in our body from an infectious person. That is who is totally infected or may not be AIDS patient but HIV patient. Right? That when they are interacted with illegal relation or any kind of transmission, blood transmission, this HIV entered through chemokine receptor. This is another term, chemokine receptor. Through chemokine receptor, suppose I am talking this, I have a connection with that mesh. So such type of receptor here, this is the chemokine receptor. From this chemokine receptor, HIV enters into the T cell, this T cell. When it enters to the T cell, what is its target? In our CD4 plus T cell, we have a nucleus. And that is the nucleus. This is the nucleus. He tried to capture the situation position with that nucleus. He try and try and try. So many processes, considering so many processes. Lastly, he entered to this nucleus and just removed that position. He just stayed out in that way. Right? So, during this time, the RCP or in a general sense, just I am telling you that HIV, that virus, and his, what can I say, that liquid actually sustained in nucleus, in the nucleus. And to some extent, it is remove the nucleus and take, that is unintegrated provider DNA. From this, it will sustain a long time, that is near about 145 days, it sustained here. And totally infect these CD4 plus T-cells. Totally infect. When he deintegrated of that nucleus, HIV, to that total cell, particular that cell, is to be infected. Not only infected, again, from that infected CD4 plus T cell, so many virus is to be released. So many virus. So many virus. These all are the virus. These all are the virus. When this cell is totally infected, actively infected, in scientific language you can say it is actively infected, and it will take near about 155 days, 45 days to active in that particular position. That means actively infected. When that cell actively infected, again, that cell release so many virus, so many virus. Again, that virus in your body, what you do? Infect another uninfected secret. And it will be continued, it will be continued, it will be continued. After 6 months, you are not understanding. After 6 months, you will feel that you are feeling bad. You will go to the laboratory, when they will take your blood, they will take, it is to be tested, they will get the result, HIV entered in your body. Then they will give some medicine, vaccine, chemotherapy, all they will be taken. Systematically, if you do this, then your life will be sustained. Otherwise, to some extent, will be done. Okay, this is the story. Parelson, Professor S.F. Parelson, you are the head. Okay. Now, this is the basically the story. This is the story. Now, Professor Parelson first, he was established in mathematical model in 1989. First mathematical model. It was a very simple mathematical model. And he has given during that time some prediction. But he was also a great medicinal doctor. Also was mathematics. He knows mathematics very well. Later on, after 89, a lot of researchers from different parts of the globe, they are doing research, if they are doing research, if they are doing research, whether the AIDS can be removed from our society or the clinicians or experimentalists or they are established, whether the mathematician can give some extra prediction using that medicine or chemotherapy, that is now countlessly counting, still not. Am I clear? In that sense, we have done a lot of what I will show you. Already a book I have published on HIV. I will give a simple example of that. That is, I have already all these things I have already mentioned you. And what I wish to tell you, that is HIV continues to reproduce. CD4 counts gradually declines from its normal value of 500 to 1200. And here another part, if preventive medications not started, the HIV infected person is now at risk for manifesting secondary infections and achieving death. Most deaths occur with CD4 counts below 50. So all these points are very much required for clinical latency to know about it. Now, just I will let you know a simple mathematical model. Simple mathematical model. That is, here x, y, z, which has been considered. X, y, and z. What is x? X is CD4 plus T-cell. X is CD4 plus T-cell. What is Y? Y is actively infected CD4 plus T-cell. And what is Z? Z is cytotoxic T lymphocytes. All these words I have used already. I have used CD4 plus T-cells, I have told you that it is coming from bone marrow, or produced from bone marrow. It is matured in China, and then it is different organs in the immune system. It is supplemented. I have told you. Again, infected CD4 plus T-cell, that is virus epitope. It will take few months, and after that, it is to be actively infected. That is Y. And Z, it is cytotoxic T lymphocyte. Just I am recapitulating it or mentioning you that when a foreign body, HIV is a foreign body particle. When it is entered in your body, our immune system will be activated. Why activated? To kill that particle, right? CTL, that type of cell who wish to try to kill that particle. That is CD4. There are so many biological features in that thing. I am not telling about it. Right? But the general conception is we are not biological person. That means we are not biologists. So we will not go to that part. Just this we have taken. That CD4 cytotoxic T lymphocytes, it will try to kill that particle since the harmful element entered in our body. With this C population, we will try to make a mathematical model. Now, I have told you that CD4 plus T cell produced constantly from bone marrow. When it is to be produced constantly in a particular rate of BSC, we are considering here lambda. Lambda is the rate of production of CD4 T cells from bone marrow which is matured in the thymus and circulated through the immune system in entire tube. Okay? Another term we have used here, P into X into 1 minus X by TA. Already Professor K. Lotka-Volta model has mentioned. Logistic fashion, logistic form. What does it mean? We have introduced that. The general sense is the production of CD4 plus T-cell, it is not to be produced unbounded. It is not to be produced unbounded. Suppose your cell is produced here every time. Okay? If it is if unbounded growth, then it is to be occurred. Cancer. Excessive growth of cell is to be treated as cancer. Excessive growth of unbounded growth. So we don't have to reach such a position that the CD4 plus T cell will not be grown or produced unbounded. That's why we have taken here P into X. X means CD4 plus T cells. 1 into this by this Tm, X by Tm. That means when Tm reaches to X, that term is to be abolished. Right? So no or the excessive growth will be shut down. Or the excessive growth will be shut down. Totally stop. Right? Therefore, we have taken this term P into X into 1 minus X by Tx. And this term is Tx. Every living organism, they have a natural model. Man is model. Today or tomorrow or after 20 years, I will not be here in that world. Right? So, in a macro level, I am a man. In a micro level, in a living organism, they have also a mortality. And that mortality rate, cell is micro level. We are in macro level. We are the population. Cell is also a population, but it is micro level. That is also a living organism. And this living organism obviously has a mortality. That mortality rate we are considered as D. So it will be reactive minus D. Right? And here also minus beta x1. What I have told you? That is X will release X CD4 plus T cell. When it is actively infected, then what we will do? We will do excessive production of ICWAMMA. Excessive production of ICWAMMA. Right? So that is the infected cell. When this infected person or infected cell will interact with an uninfected cell, they will be interacted with each other. They will, because in your body, infected cell always attached to the uninfected cell. Right? All cells are flowing through your immune system. So infected cell will interact or accumulate with each other, obviously in a particular rate. That rate which we have considered here, beta. So beta is following the law of mass action. What will be the term? Term will be minus beta xy. Right? That beta xy obviously reflected in which population? Infected population. That has been done here. Again, A is the mortality rate of whom? A is the mortality rate of infected virus, infected cell. And this is KYK. Minus KYK means when the foreign body particle enter in your body or CPL2, CTL try to kill it. Right? CTL try to kill it. We are considering that interaction to each other at a rate K. Z is interacted with the infected CD4 plus T-cell, that is where the enemy. Now Y is now the enemy because he containing the infected virus. He tried to kill that cell. Okay? And considering the following law of mass action, the term will be minus KY. Right? And CTA, it must be generated from whom? Because he is interacting with infected cell. That infected cell generated whom? But the generated virus. That virus ultimately matched with whom? Infected cell. So ultimately cytotoxic nucleosides will be generated from the infected. And that's why the term here is what? That means when we are making or formulating the mathematical model of rate of change of cytotoxic lymphocytes, that is DZBT, obviously the term will be different. And even this J has also a mortality rate that has been revealed here, that has been revealed here. So now this is a nonlinear set of differential equation. Now it is a nonlinear set of differential equation. Now we have done it. We have solved it. Our contribution in this work. 15 years ago, I have done this work. 15 years ago. Our contribution was only we have considered here this time. That is the holistic fashion. Because Carlson has not introduced the holistic fashion. We have obviously we have seen, we have studied so many literature, and we have thought that the CD4 plus T-cell production will not be produced uncommon. That's why we have introduced it. And we have studied this and not going to. Now it has been published in 2012, 13 years ago. 13 years ago. It's a good work, and because it has been cited so many papers. What we did here, just I have given you a story. The antiviral drug treatment along with immune activator IL-2, a control-based mathematical approach of HIV infection. What we did here, to kill the virus or infected cell, a general medicine is called HAART. H-A-A-R-T. HAART. H-A-A-R-T. This is called HAART. H-A-A-R-T. HAART. HAART means highly active, highly active antiretroviral therapy. Highly active antiretroviral therapy. HAART. HAART means highly active antiretroviral therapy. This HAART actually a combination of that. Suppose when you go to the doctor, then if the doctor gives you the antibiotic, then obviously he will antacid or antacid. Am I right? When doctor will give you the antibiotic drug, then obviously he will give you a antacid, as we call it, if you take that medicine, no other situation not to be offered for taking that drug. HAART, so it is a combination of. HAART is antiretroviral therapy, a combination of. And this drug, it is on its RTI. On its RTI. RTI. RTI means RTI. RTI. And another is PI. RTI means reverse transcriptase inhibitor. Reverse transcriptase inhibitor. RTI means reverse transcriptase inhibitor. And PI means protease inhibitor. These two drugs, all I try to give, even now, when a HIV patient goes to a doctor, the initial dose is HAART, and that HAART is basically a combination of two drugs on its reverse transcriptase inhibitor and PI is protease inhibitor. But it works. It works. RTI. It tries to kill the infected cell. And PI, it tries to kill the new virus. That is the new virus that is generated from the infected cell. The drug tries to kill the infected cell. That's why. And PI, that means it tries to kill the new virus. In this world, what we did, we have considered a four compartmental mathematical model. And we have given two graphs. One is protease inhibited and another is IL-2. IL-2 is interleukin 2 cytokines. It's a cytokine. We have given these two drugs. And we have introduced these two drugs in this position and also in this position. Cytotoxic T lymphocytes, the work of these two drugs is PI will kill the new virus. Our target is to kill the new virus. And another task was how we can activate our immune system, or we can try to more active our immune system. That's why we have given these two drugs. And these two drugs we have given in two categories. First, we have tried optimal, and second, we have tried impulsive way. Independent impulsive way. We have seen that this is very much actively works and give some prediction here how we give this drug that has been checked by these research firms. Furthermore, a lot of works which we have did on HIV that you can check through my webpage. I am not going to another discussion anymore. These all are the works awareness program. Now just I will let you know the autoimmune disease. That was the infection disease, and it is an autoimmune disease. Autoimmune disease. I have given the lecture on the autoimmune disease in my first part of lecture. Autoimmune disease. What does it mean? It means that sometimes our body thought a foreign body part will get entered in our system. Sometimes our body think that a foreign body in a foreign body article, foreign body particles enter in our body. Or it will be activated. Usually, what ultimately the disease occur in this situation, that type of disease called psoriasis. Psoriasis. And basically, the population dynamical model of psoriasis. First, we have formulated. Population dynamical mathematical model on psoriasis. I'll show you that few minutes later. Population dynamical model of psoriasis. First, we have formulated this one. And another model shared from Professor University of Edinburgh. He has formulated a mathematical model in 2008. And that work, it is very much density dependent work, but it was not a population dynamical model. No such mathematical model during that period has formulated. But later we have, from 2009, we are working this disease. First, we have formulated, and last we have completed work that I will show you, that the psoriasis or the disease psoriasis. So just I will let you know that is what is psoriasis. Psoriasis is a common chronic autoimmune inflammatory skin disease. The skin disease and characterized by T-cells mediated hyperproliferation of epidermal keratinocytes. This type of skin disorder is characterized by macroscopic and microscopic skin alteration. So basically, it is a skin disease that I will show you. Skin disease, and this is the dead skin. Below that, it is the keratinocyte layer. I will show you the all pictures. This is the outlook of psoriasis. This is main causes. Psoriasis seems to be an inherited disorder that it is passed down through families. Psoriasis probably occurs when the body's immune system mistakes healthy cells for dangerous substances that I have mentioned, and skin cells grow deep in skin and normally rise to the surface about once a month. And in person with psoriasis, this process is too fast and dead skin called build up on the skin surface. Now this is the psoriasis, and clinical presentations well defined and sharply demarcated. This is covered by white Silverne scalis, and this is distribution, the psoriasis. Globally, the affected pupils of psoriasis. This is the chronic plague of psoriasis. This type of disease, this is the chronic plague of psoriasis in arms. You can check gouty psoriasis. This type of psoriasis, sexual psoriasis, all these erythromatic psoriasis, these are the psoriasis. This is also the palmoplantar psoriasis, and this is scalp psoriasis. Scalp psoriasis, or actually scalp psoriasis. This is scalp psoriasis. This is the psoriasis, nail psoriasis. Nail psoriasis, all these are nail psoriasis. So, and this is the psoriasis arthritis. Psoriasis arthritis. Now, considering all this knowledge, we wish to try formulate a mathematical model. In 2009, we have formulated the first basic mathematical model. This is the bone marrow. This is the Simon thymic processor. This is the thymus. And this thymus, basically, where the cell T cell is to be matured. And from this thymus, on T cell, this immune cell is to be released. That is called T cells. We have considered different T cells in HIV. We have considered CD4 plus T cell. Amalgamation of all these two T cells, actually CD4, CD8, CD20, CD64, all these T cells, naming as T cells, and another immune cells which we have considered here T cell, that is dendritic cell. Now, this is the This is the healthy skin. It is non-psoriatic. And just you have to follow here. This is the scaly and this is the psoriatic between the skin condition is this. Now, this is our first model in 2009. We had published, and I am not, this is the basic simple mathematical model. That is, this is the T cell, this is the dendritic cell, and this is keratinocyte layer. Actually, keratinocytes is the causal effect of psoriasis. Keratinocytes is the causal effect of psoriasis. And this psoriasis, we have formulated a basic mathematical model. And because of, I have earlier mentioned you that T cell and B cell, T cell means immune cells, both are immune cells, and these immune cells are produced from the bone marrow. It is to be matured and separately it is to be circulated in different parts of the immune system. So that we have considered A T cells and A dendritic cell and K is not a immune cell, it is the keratinocyte cell population. Right? We have the three layers, epidermal layer and dermal layer, probably you know. That upper portion is the keratinocyte cell population. Below that, epidermal layer. Below that, dermal. So all these are the skin. The keratinocyte, this is the dead cell. Below that, the keratinocyte cell layer population. When psoriasis occurs, it is to be reflected on your skin. Or I have shown you the picture. So, this is very much associated with cell, dendritic cell, and keratinocyte cell population. This keratinocyte cell population ultimately the causal effect of psoriasis. That's why we have considered K. Now, T cell, it is continuously produced from where? Bone marrow, we have considered at a level A and produced at a level A. Again, dendritic cell, it is also continuously produced from bone marrow. So we have considered it is a B. This T cell and B cell, T cell and B cell, that is immune cell and dendritic cell, T cell and B cell interact with each other or accumulate with each other with respective rate, that is delta and beta. Considering the following law of mass action, the term will be delta ln and beta ln, and all I have told you, the all living organism has a natural mortality rate. So mu L and mu dash L are respectively the mortality rate of T cells and dendritic. Right? Now, these when actually T cell and dendritic cell at each other accumulated with each other or to be focused ultimately gathered in such a position where keratinocyte art exists. That tells keratinocyte so that this interaction must be upgraded or moving towards the keratinocyte cell population, and that has been introduced here. Delta ln plus beta ln, that is delta plus beta ln. We have considered that delta plus beta equal to beta. That is to be revealed here as beta ln, and it has the natural bond. So we have general study. It was the general study. We have in 2009 we have done this work, and later we have taken a simple graph that we have done.